So we all know that list is a container which supports storing objects of multiple types. So you can have integer, you can have string, and you can even have a further list as object in this container. So what we are interested is we are interested to know the time complexity of CRUD operations on the list. So I hope you recall what we mean by CRUD operations. C stands for create, R stands for read, U stands for update, and D stands for deletion operation on this list. Now tell me, so can I access any element of list by using index? Yes. So if I say list of one, A of one, if A is list, right? If A is list and it contains these four numbers, and if you say A of one, you get output as one, right? If you say A of, if you say A of one, you're gonna get one because these are zeroth index, like the index zero, index one, index two, and index three. So list is an index data structure. Now let us discuss in terms of algorithmic complexity. If I have any data structure, if I have any data structure that is indexed, I mean you are maintaining an index, and with the help of that index, you can always access the element. For example, here I have A, B, J, K, L, and O. Let us suppose I have this letter. So now, whenever I have an index, it means that with help of index, I can directly access this element. So maybe in terms of your C language or in terms of C++ language, what you have is you have a base address, and whenever you want to access any element, you have to do base address plus index, and you directly go to that memory location, and this element is accessible outside, right? So if we have a data structure where every memory location of that data structure is indexed, then what would be the retrieval time? So if I say what would be the time complexity of any read operation on such kind of data structure? What do you think? So let me test your knowledge. Like, would it be O of n or would it be O of 1? So what do you think? If I have a data structure where every memory location is indexed, whereby using some most of the time only one or maximum two operation, you can always directly go to that index and you can retrieve that element. So what would be the complexity in such cases for read operation? Would it be O of n or O of 1? Yes, the answer for that is O of 1. Yeah. So now that you know that list is an indexed data structure, list in Python is the indexed one, and actually in Python, whenever you want to read any element from the list, the insertion, time complexity of that is always O of 1. This is the right answer, right? So now, now let us make this slightly complex. Now what we're going to do is we have defined a time complexity for read, right? Now, what would be the time complexity for update operation? So update means here instead of k here, I want to store z. What would be the time complexity? So time complexity of update operation on list on any of the existing elements. What I'm talking, the time update. See, update always occurs on existing elements. So if I want to update any of these locations here, what I'm supposed to do? I need to go to that index. So I want to modify element at index 3. So go to that index, write the new value. I mean overwrite the new value. So what kind of complexity is O of update? Update is also O of 1. So update operation is also O of 1. Now the confusing and the tricky part occurs for create and update. So let create and delete. So let us talk about create operation. So let us suppose When I want to create a new element, let us say I want to create a new element X and I want to store it in that. So when I want to create a new element, I have three possibilities. Either I want to add it here at the beginning, or I may want to add it at the end, or I may want to add it somewhere in between, maybe somewhere in between location. So I'm not sure. Now let us talk about case one. So in a case one, if I want to add element at the beginning of this array, I can always add. I can create a memory location, I can keep it. So creating a new element and memory location is one instruction. After that, is it just enough that I append the element to the front? Is it just the end of the routine? No. But since the data structure is indexed and you have added a new element to the beginning of the this list data structure, you have to re-index all the elements. So re-index all the elements means you have to just delete the previous index and re-index a new. Like now this X will become new zeroth index, 1, 2, 3, 4, 5, and 6. So adding an element at the beginning of this list data structure, what's the complexity of that? The complexity would be O of n. So you might ask me, why O of n? So though the time complexity required to create new element and add is constant, it might require only two instructions, but you need n re-indexing operations. Only after doing n re-indexing operation, list would be accessible to user so that he can access it safely as per the Python semantics, right? So adding element to the beginning of the list would be O of n. At the same time, inserting any element in between of this, let us suppose in between B and J, I want to insert element X. Even if you insert that, you still have to reindex. You have to reindex all the elements before this. You have to reindex all the elements after this. So no matter whether you are inserting in between or beginning, you always need to reindex n elements. So inserting at the beginning or inserting in the middle, the time complexity is O of n. The best case occurs if I want to index at the end of that list. If I want to add an element to the end of that list, what is an operation? I just need to add element plus, is there any need to increase the reindex any other existing elements? No, you have to just add a newly index to the newly added element. So adding a element to the end of that list, the time complexity of that would be O of 1. Are you getting that? Let me know if you have understood this. So adding element at the beginning of the list, time complexity is O of n. Adding element in between the list, time complexity is O of n. Adding element at the end of the list, time complexity is O of 1. So which is constant time complexity. Adding element at the end of list is constant time complexity and we call it as O of 1. Now, can you guess time complexity for deletion operation? So if I go here, let me draw again. So A, B, C, J, K, L. Okay. Now I want to do delete operation. So now if they are at index 1, 2, 3, 4, 5. So deleting first element, does it cause reindexing? Yes, because if you delete this, the next zeroth index will be B. So they have to be reindexed, right? If I delete the first element of this, the same also applies if you delete in between any element. If you delete in between element, it requires reindex. It may not be n, but almost equivalent to n. So deleting from beginning or deleting in front of in middle of that list, the time complexity is O of n. But deleting end element, deleting the last element here, will not result into any change in index. Just you need to remove this, the last index, that's that. So removing element from the end of your list will be, the time complexity of that would be O of 1. Okay. So can you give me a quick feedback that have you understood these operations? Raise your hands if you have understood this. Okay, fine. So this was something related to Python lists. Now, based on this understanding, what we'll try to do is we'll try to uh, solve this problem. So if you read this problem, I hope you can see the screen and you can understand it. What I need to do in this here, I need to implement a class called as Minstack. So basically, I'm implementing a stack operation. So I'm implementing a stack. And what operations I want in this stack? I want the operations of push. I want pop operation, and I want to implement top, and I want to implement get main. Right. So what is more important to me is understand the sentence called as retrieving minimum element in constant time. What it is asking for? I need to design a stack that supports push, pop, top, and retrieving minimum element in a constant time. So I hope you're getting or I hope you started visualizing the logic for that. So when I say constant time, I'm thinking of O of one complexity, right? And I hope I did not tell you that in a stack. So let me give you an operation. So let us work on this, and then we will try to write a code. What they are asking me is they are asking me to implement a stack, right? They are asking me to implement a stack in which the push operation, so push of one element, they are asking the complexity of that to be O of 1. They want to implement pop operation where we remove one element out of the stack. They want this to be O of 1, and they want another operation called as top. What does top operation in stack do? It returns whatever element which is at the top of that. For example, x, z, 1, 2, 9. So when I say top, what it does, it returns the whatever element which is at the top of that, or whatever element to which the top pointer is pointing to it. So they want these operations to be O of 1 plus what additional they want? They want to implement a method called as get minimum, right? They want to implement a get minimum, and what it does is whenever and whatever may be the status of stack. So right now 9, 2, 1, and let us call this as 2, and let us call this as 10. If my stack has these elements 9, 2, 1, 2, 10, and if I call get min, it has to return me the element 1 because 1 is the minimum among the elements inside this stack, right? I hope you're getting that. So after get min, let us suppose I do pop operation. How many pop operations I do? I do 3 pops. After that, if I do 3 pop operations, this element will be out, this element will be out, this element will be out, right? After doing 3 pop operation, if I now call get min, what answer I am expecting? 2. Okay. So after this, if I do push operation, push 0. So now the stack will be 9, 2, 0. And now if you call get min, then I need to get 0 as a minimum. So what is the tricky part in this problem is to get a suitable implementation for this get min operation so that I always get the minimum element present in the stack. Now, what is more tricky is that this operation of retrieving the minimum element from the stack should be constant time complexity, like it should be O of 1. I mean, no matter what is the length of the stack size n may be 3 or n may be 30,000 in a constant set of instructions, maybe 1, 2, or 3, or 4. By using 4 set of operations, you should be able to tell what is the minimum element across the stack. So can anyone, did anyone get, have you understood the problem first? Let me know if you have understood the problem, what we have to implement for. You type yes or no. So just let me know if you have understood the problem. If you have understood, raise your hand. Okay. So how should we implement that? Let us think of the logic, and then we will talk about the implementation of that. What we should go and what we should implement this for. So going further, I want to implement a stack, then I need to decide a data structure. So if I want to decide an inbuilt data structure, I have these options, right? The inbuilt data structure, which can let me store multiple integers, are following. List is one data structure available to me. Set is one data structure. Dictionary is one data structure, and tuples is also a data structure which lets me store set of collection of integers. Now tell me, what data structure should I use to get my stack? What do you think? So you are visualizing stack in this way. So what we will do is, instead of visualizing in a vertical order, what we will do is we'll try to visualize this horizontally. So let us visualize stack in this order. Or okay, so you add an element and you pop. You add an element and you pop a element from this, right? So what data structure would be best for this? Remember, I want the stack's basic operation, push, pop, and top, to be O of one operation. Tell me which container does that. As of now, whatever the containers which you have studied, which container lets me do this addition of element in O of one, removal of element in O of one, accessing element in O of one. What data structure does it as of now? What is the data structure in Python? Which lets me add element in O of one, delete element in O of one, and access element in O of one. We did see right now, right? What is the data structure? So why does it take so long to get this? It's a basic data structure which we just saw, right? Just now we saw that. Adding element to the end of that list, deleting element from the end of the list, and accessing any element in the list. Since list being an index data structure, the operations time complexity will always O of one, right? So given this understanding that I can add element and delete from the list, we will now use list to implement the stack. So to implement the stack data structure as an underlying data structure, we'll rely on list, which is a Python built-in container. The only care which I need to do is, whenever I implement stacks push and pop operation, I need to always rely on adding and deleting element with the end of that list, not beginning of this list. If I implement stack using list, and when for a push operation I am adding element to the beginning of the list, and for pop I am deleting element from the first, then I am violating these conditions. So anything which you add and delete from the beginning of the list, that will take O of n. And this is not what I want. This problem is not asking you to implement these operations as O of one. They are asking you to implement as O of one operations. Remember, no matter what language, wherever you are asked to implement stacks, push, pop operation, those have to be implemented always as O of one. So you might have taken some pointer or something you have done, but you are doing this, then that should be something very wrong. Like, do not do that. Most of the times in interviews, this question is asked. So whenever someone asks to implement stack using queue, stack using list, stack using some data structure, they are expecting whether are you implementing this push pop operations in O of one order of complexity. Okay, so I can now use this. Now tell me what should be the logic I need to get for means minimum stack. How do I get the minimum stack here? So I want to implement a get min element which retrieves the minimum element in this stack. How do you think what could be the logic for that? So before I tell a logic, I want some of you to discuss the logic. See, I now I can implement push operation, pop operation, top. I have figured out by using list. I need to just add an element, add or delete element from the list, and I can implement that. But the issue is how do I implement the method to get the minimum element in this stack? Can any student just give a rough logic? Like, no matter it could be right or wrong, but I want you to come up with a logic. Give some logic to this. Omkar has some one. What is asking, sir? While pushing, you can also push. What is minimum? What is minimum till that point? So, where would you store that?
सर आई मीन एलिमेंट के साथ हम वो भी पुश कर देंगे कि उस पॉइंट तक मिनिमम क्या है।
हाँ, तो वो आप पुश करेंगे, ठीक है, दैट इज फाइन. दिस इज ऑलमोस्ट अ करेक्ट लॉजिक. बट वो पुश कहाँ पे करेंगे? सेम स्टैक में या दूसरा
सेम
कुछ ऐसा डेटा स्ट्रक्चर मेंटेन करोगे उसके अंदर होगा?
सर सेम स्टैक में भी पुश कर सकते हैं ना, क्योंकि पॉपिंग के टाइम ही या फिर मिनिमम के टाइम हमको डायरेक्टली टॉप एलिमेंट का वो जो मिनिमम है वो एक्सेसिबल रहे।
ठीक है, अगर एज्यूम करो पहले मैंने स्टैक में जीरो ऐड किया है और उसके बाद 1 2 3 4 5 6 ऐड किया है, तो जीरो जीरो मतलब अभी 7 एलिमेंट्स है, 7 एलिमेंट में से जीरो मिनिमम है, ये कैसे फाइंड आउट करोगे?
सर जैसे हम एक टू एलिमेंट्स का टपल पुश कर सकते हैं जिसमें 0,0 क्योंकि मिनिमम भी वहां तक 0 होगा। उसके बाद 1,0 2,0
तो
थ्री
आप
कॉमा
क्या कर
जीरो
रहे हो कि यू आर सेइंग दैट अगर जीरो पुश करूंगा तो 0,0.
यस सर, क्योंकि सेकेंड एलिमेंट मिनिमम रहेगा उस पॉइंट तक।
तो यहाँ पे आप एलिमेंट का ये कर रहे हो आप. मतलब अगर मेरा इसके बाद अगर मैं 1 ऐड करूंगा तो 1,0, अगर इसके
यस
बाद
सर।
2 ऐड करूंगा तो 2,0.
यस सर, वो
ये
पहले वाले एलिमेंट के मिनिमम से चेक होगा कि सेकंड एलिमेंट बदलना है या नहीं।
ओके. तो ठीक है, अगर इसके बाद अगर आप -1 ऐड करते हो तो -1 ऐड करते वक्त आप चेक करोगे
जीरो
जो
से
जीरो
कंपेयर
पे
करेंगे
ये कंपेयर करोगे, इससे अगर लेस है तो
तो
ये
माइनस
अगर
वन करेंगे।
0 1 2 और यहाँ पे 3 ऐड करेगा. ओके.
नहीं सर, वहाँ पे -1 आएगा ना, क्योंकि वो पॉइंट तक -1 ये है, मिनिमम है।
यहाँ पे -1.
-1 पॉप करते टाइम सिर्फ वही करेंगे, -1 करेंगे। अगर पॉप भी हो जाएगा तो भी मिनिमम मेंटेन रहेगा ना, क्योंकि जीरो उसके बाद जीरो ही मिनिमम है।
ठीक है, तो यहाँ पे अगर जीरो आप यहाँ पे क्या करोगे कि -1 और -1 स्टोर करोगे आप।
यस सर।
ओके, अगर ये पॉप करोगे तो
सर जैसे अगर गेट मिन करना है तो हम सीधा टॉप एलिमेंट का जो मिनिमम है वो रिटर्न करेंगे। उसके बाद अगर पॉप करने के बाद वापस गेट मिन कॉल कर दिया, फिर भी जो 4 0 है वो मेंटेन रहेगा, क्योंकि उसके बाद सारा जीरो ही है मिनिमम।
ओके। फाइन। ये भी ये अगर मिनिमम कांस्टेंट ऑपरेशन ही है O(1) में भी आएगा। बट इसका मतलब इसका डिसएडवांटेज क्या है कि आप ये जो जीरोस है ना अननेसेसरी एडिशनल स्टोर कर रहे हो आप। सो ठीक है, टाइम कॉम्प्लेक्सिटी वाइज है बट स्पेस कॉम्प्लेक्सिटी वाइज मतलब ये जीरो अननेसेसरी स्टोर कर रहे हो ना आप।
सर फिर पॉप करने के बाद हमको कैसे पता चलेगा कि मिनिमम कहाँ तक है?
हाँ तो एस कैन आई डू दिस बेस्ड ऑन योर लॉजिक। आई विल मेंटेन माय स्टैक एज इट इज, बट और एक स्टैक मेंटेन करूंगा मैं एंड इसे कॉल करूंगा मैं मिन स्टैक। तो अगर मैं जीरो ऐड करता हूँ, जीरो अब तक का मिनिमम है तो यहाँ पे मैं जीरो कर देता हूँ। उसके बाद मैं 1 ऐड करूंगा, 1 इससे मिनिमम है या नहीं, तो मैंने यहाँ पे ऐड नहीं किया है। उसके बाद 2 आ गया नहीं, उसके बाद 1 आ गया। जब -1 मैं ऐड करूंगा तो -1 इज ऑब्वियसली लेस देन द टॉप ऑफ दिस टैग, सो आई ऐड -1।
यस सर, स्पेस बचेगा डेफिनेटली।
हाँ, उसके बाद अगर मैं 9 ऐड करूंगा नहीं होगा, तो जब मैं पॉप करने लगूंगा ना तो -1 पॉप करूंगा। सो हर पॉप का ऑपरेशन मैं चेक करूंगा कि ये एलिमेंट इक्वल है तो यहाँ से भी इसे निकाल दूंगा। तो जब ये पॉप हो जाएगा तो ये निकल जाएगा। तो गेट मीन मतलब इसका जो टॉप है ये आ जाएगा मतलब।
यस सर।
ओके। ओके, ठीक है, तो इसके अंदर मतलब स्पेस बचेगा ये।
यस सर डेफिनेटली।
ओके, ठीक है, ये लॉजिक, दिस लॉजिक वर्क्स, इट्स ओके। ओके, सो other students, were you able to connect to this logic? If you were able to connect to this, you just raise your hands. Just raise your hands and let me know if you have understood this. Okay. So, shall we try to write the code based on this logic? Let us try it. I think it's almost maximum. We have 10 minutes, but let us try to write a code for this. Okay, so I'm on this window. So what we are trying to do is we have a constructor here, and we need to initialize our data structure here. Recall yesterday's lecture. So this whatever data structure which I'm gonna initialize, that should be accessible within push, pop, top, and get mid, right? So यहाँ पे what I'll do is I'll create two lists, right? So one I'll call stack of numbers, stack of numbers, just digit. And if I want this to be accessible for all, I need to say self dot stack of numbers, blank list. और एक लिस्ट ले लूंगा मैं यहाँ पे self dot min stack to store the minimum elements, right? So whenever I get a push operation, what I need to do, if I get a push operation, what is the element which I'm getting, that this has to be added to this stack of numbers. So self dot stack of numbers. If I want to add at the end of the list, what I need to do is I need to always call add. So list has few operations. I'll tell you. Whenever to list, if you call see, to add an element to a list, we have a method called as append. To this append, you need to pass the element x. So append method of list will by default add element to the end of that list. Remember, so these are the method of built-in Python container, right? But tell me one thing, when I push the element to the stack of numbers, I need to also take care of this minimum stack. So what should I do for that? Or else let us do one thing. We'll come back to that logic. Let us basically write the basic implementer operations. So if I want to implement pop, you need to remove element from that. What I need to do is stack of numbers. If you want to remove element from the end of the list, we have a built-in method called as list.pop, which will automatically remove number which was at the end of that list, right? So I was able to add push operation, I was able to add pop operation. And what should I do if I want to retrieve the last element of list? See, inside top, I need to access the element which is at the top of that list. I don't want to remove it. So how do I access the last element of the list? Whenever I want to access the last element of the list, see, stack of numbers, I want to access last element. So what you will do? Either you can say length of stack minus one, it will do all that one, fine. But remember, lists are very elegantly defined in Python. Here, you can do something called as reverse indexing as well. In Python, you can always give minus one, minus two, minus three as an index. So in Python, whenever you give minus one as an index, it denotes the last element. Minus two means second last. Minus three means third last. I hope you're getting that. So we call it as reverse indexing in Python. So this is a good example to learn the syntax of lists and Python syntax. So self dot, here I need to call return statement. Return self dot stack of number minus one. And here I need to check get minimum. So let us see some constraint. The constraints is that methods pop will always be okay. This is what I was looking for. They have mentioned a constraint that methods pop, top, and get min. This pop, top, and get min will always be called on non-empty stacks. So I need not write a condition to check if stack is empty. Should I return something? No, I need not worry. The program itself, the problem setter has taken care that the pop, top, and get min will never be called on empty stacks. And almost 3 into calls will be made. Okay, so this value itself denotes that this is a very big problem. So I need to write a most efficient code for this. So this is what. So I need not worry about what will happen if stack are empty and I call pop and top, because that condition is relieved here. The only thing remaining is push operation. Now tell me, when I do a push operation, I need to also take care of this minimum numbers, right? So when I push this element, what should I do? When I push this element, what should I do? Along with pushing this element in the stack, I need to see if this is minimum. Then I need to add it to the other element as well. So how do you do that? So maybe what we will do is, while initializing the minimum stack, or if I if I check the length of that, if I check the length of min stack. So when you're pushing that, what you're doing is you're checking the length of min stack. If it is equal to 0, means min stack is empty, right? If min stack is empty, what I need to do, I can push this. This will be the first. Your stack is having one element, and if your stack is one element, the same element will be the minimum element for the entire element of stacks, right? So here, what you will do, min stack dot append x. If it is not, if the length is not 0, it means that already this min stack has some elements into that. So you will only add element to min stack else in else block. What you will do, you will only add if whatever element which is at the top of this stack, min stack of -1 will give you the last element present at that list. So if min stack of -1 is greater than the current element which is being added, then append that. So whatever you had here at the top of that stack is not the minimum. The one which you're adding is minimum. So what you need to do? Min stack dot append x. And here wherever you are calling min stack, you need to prefer it by self dot because this is part of this object. Self dot. And here too it would be self dot, and here too it would be self dot. Okay, if it is the case, I think this will take care of adding the minimum element in the min stack. Now the question arises is what will happen during pop. So see, here you are removing the element at the pop, but if the element at the whatever the element which you are removing, if this element is equal to the element on the minimum min stack, even the element has to be removed from the min stack as well. So now if you check a stack of pop, let me quickly check that lists pop operation whether it returns element or not. So I want to see with what pop element returns. Parameter. I'm checking the Python documentation. Has any student tried what pop element? Pop, does it return the element or it just removes that? Yes, pop. I just did a check in the Python documentation. So whenever you call pop, it does return the last element of that list. It removes them, and after removing it returns that. So what I'll do is I'll take a small variable temp. Then what I'll do is if temp equals self dot min stack's last element, means you are removing some minimum element. If it equals, what you need to do is remove from that as well. Self dot min stack dot pop. Just remove it from that. Okay, so I think we are done with the basic cases. Anything which we missed? Returns element after popping. Okay, yeah. So shall we run? Do you think we missed anything here? Okay, so let me execute this and let us run this. So we'll see if our basic test cases pass, then it should work. Okay, what it says at line number 33, indentation block, line number 33. What was it, line number 33? Uh, what is it that? I don't think we. Okay, I think yes, we are yet to even write this method, right? So if it is a get min, what I need to do is I need to directly return whatever is at the last of min stack. So min stack last element. Return whatever it is at the min stack's last element. And remember, whenever you are accessing any of this by indexing, this is always a constant operation. This is always a constant operation when you access anything by index. So now let me run. Okay, so at least the basic test cases have run. So let me submit and see what happens. Okay, what it says, I think for some it is giving a wrong answer. Can you see what it says? Our solution get min stack return. Uh, So what is let me see. Can anyone figure out? This is a very small silly mistake. If you check here, where is our code? So when you implement it here, you have checked greater than or equal to x. Think of a case where my stack can have multiple elements. I can have 0, 0 twice. I can have 0 and 0 twice. So this has to be actually uh, greater than or equal to. So you need to check that. Are you getting? So now we have a solution to for all this entire problem. So now you see success. It indicates that my thing is executed for almost all of them, almost in the sense of all cases. So the most silliest mistake was this. This was what I had, and Omkar has already figured this out. The I hope you're getting why it is greater than or equal to. See, that is because I might have a case where I might have multiple minimums, right? So let me talk about this situation is specifically talking about a situation where let us suppose I have 0, 1, 1, 2, and 3, right? This is the stack right now, and this is my min stack. So min stack is containing 0. So now let me what I am doing is I am adding a new element called as 0. This is new element. This is new element 0 I have added. So initially what I was checking is I was just checking whether this is less than or equal to. So it is 0 less than 0 is always false. So this was 0, right? This was 0. Fine. After this operation, let us suppose after adding a push 0, so I was only checking less than or equal to. After doing push 0, I called pop. If I do a pop, what happens? It removes the top element. So the top element has been removed, and I was checking if the top element and the top on min stack is equal. Are they equal? 0 and this, are they equal? Yes. If they're equal, I am also deleting this pop. So this stack has literally become empty. But still, I did not. I couldn't figure out this condition that there could be multiple zeros minimum. So after this, the new stack is 0, 1, 2, 3, and on this when I call get min, it has to return 0. But when it went to this stack was empty. So it is trying to access an index -1 on an empty stack. So this was giving me index out of range exception. So that was indication that this figured out. So I had to check whether it is less than or equal to. So in our case, the code becomes greater than or equal to. Fine. I've understood this code. I hope you have understood this. So